Alright guys, we are going to start chapter 1 here today. We are going to hit chapter 1, lessons 1 and 2 in this same video. At any point during this video, if you have any questions or you're copying down notes, go ahead and pause this and we can work through it. You work through it on your own time. So again, feel free to pause it if you have any questions. Feel free to come back to this whenever you're doing your assignment. So, section 1.1 is on graphs and graphing within the coordinate plane. So first thing, we're just going to remember what the Cartesian coordinate system looks like, or everything we based off of. We have our x-axis, we have our y-axis. If we want to graph points, anytime we have a point in an ordered pair, the first term is our x term, second term is our y term. So I have 2 points here I want to graph. I have 4, -2, and -2, 4. So for -2, we need to go to the right 4, up 2. That's our first point. We'll call that one A. Second one, we have -2 and 4, so we have 2 to the left and up 4. We'll call that point B. Alright, and that's just a reminder how the coordinate system works for us. Alright, so if we want to graph an equation in 2 variables, x and y, it's the set of all points x and y whose coordinates satisfy that equation. So looking at this guy below, we have a absolute value equation. Alright, it's the absolute value of x minus 5. And in this case, we want our x values, our input values, to be -2, -1, 0, 1, and 2. So all you'd have to do for each one of these is plug in the x value, see what you get for y, and then that would be your point. So if I plug in a -2, the absolute value of -2 is 2, minus 5 is going to be -3. Absolute value of 1 is 1, minus 5 is -4. Absolute value of 0 is 0, minus 5 is -5. Absolute value of 1 is 1, minus 5 is -4. Absolute value of 2 is 2, minus 5 is going to be -3. That's going to give us the points of -2, -3, -1, -4, 0, -5, 1, -4, and 2, -3. Now we can graph these on our graph here to the right to see what this graph of this equation is going to look like. So we have -2, -3, -1, -4, 0, -5, 1, -4, and 2, -3. And then just go ahead and connect your dots. Now remember, lines go on infinitely in both directions. It looks like that. And if you remember your parent functions from last year, the absolute value of x should look something like a v, like we have on the right. Alright, so looking at this graph now, I'm going to use the graph to determine the x and y intercepts, if any. Now I'm going to extend this a little farther so we can see where we're at. Go through there, and goes through there. So, x-intercepts. X-intercepts is where the graph would cross the x-axis. So looking at this guy, we're going to cross at 1, 2, 3, 4, 5. And on the negative side, 1, 2, 3, 4, and 5. So our x-intercepts are going to be -5 and 5. Our y-intercepts, we only have one here. Our y-intercept is where we cross the y-axis or the vertical axis. We're 1, 2, 3, 4, 5, and it's a -5. So intercepts, you just have to look at the graph and see where it crosses the x and y axes. So that was just a lesson that is just a reminder for us. So it's not a very long lesson, so we're going to continue here into lesson 1-2. So lesson 1-2 is linear equations and rational equations. We're looking at solving both of those. So first off, we have a question here. Which one of the following is an equation? Well, the important thing for something to be an equation, it has to have an equal sign. So this one would be an equation. This one is not. This one would be an expression. So an expression does not have an equal sign. An equation does have an equal sign. And hopefully looking at the words, you can see, equal sign. All right, so if we're going to solve linear equations, we have a few steps here. Just want to highlight these, make sure you write these down. The steps to solve linear equations, I paraphrase these. This is about a 7-step process, but I paraphrased to make it easier for us because it's review. Step 1, you want to remove your grouping symbols and combine like terms. So if you have parentheses or something like that, use your distributive property, whatever you might need, and combine like terms on each side. Number 2, get the variable on one side and all whole numbers on the other side. So make sure, whether it's to the left, to the right, it doesn't matter. Just get all your x's or y's or whatever your variable is, get all those on one side, all the whole numbers on the other. Step 3 is isolate the variable. You can do that, addition, subtraction, and then multiplication and division to get the variable all by itself. And if you ever have any with fractions, you want to multiply by the LCD, and in an equation, that will eliminate the fractions. All right, so a couple definitions to hit. Values that satisfy an equation are called the solutions or the roots. So say you solve an equation, you get x equals 2. 2 would be a solution of that equation, or it could also be looked at as a root of that equation. So by definition, a linear equation in one variable x is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. Linear equations are often called first-degree equations. First-degree equations because that is the power of our x term. A couple more equations. So an equation with no solution is called inconsistent equation. An equation that's true for all real numbers for which both sides are defined is called an identity. All right, this would also be an identity equation would also be an equation that we would be talked about before as an infinite equation or infinite solutions. And a solution that is true for some values of the variable but not others is called a conditional equation. All right, so we're going to look at a set of equations. We have 1, 2, 3, 4, 5, 6 of these that we're going to solve, and we're going to classify those based on whether they're a conditional equation, an identity, or an inconsistent equation. All right, and one more thing, just to add in a conditional equation, if you get an answer like x equals whatever that number might be, that one is conditional. All right, so we're going to solve the following equations. First step, we want to get rid of the parentheses in this, so I have to distribute here and I have to distribute here. So I distribute the first one. I'm going to have 3 times my 2x, which is going to be 6x minus 3. Second set, I have to distribute the negative sign, so I'm going to have negative 6x plus 4, and that's going to be equal to negative 9. Combine like terms. 6x and 6x is going to go away. Negative 3 and negative 4 is going to be a positive 1. Sum with 1, left with 1 equals negative 9. All right, this is not true. That is not equal to each other. So this one would have to be inconsistent. Should also be a no solution. All right, next one. Start with our parentheses. We have brackets and parentheses. So let's go inside the brackets and start with the parentheses here. I'm going to distribute the 3. So I have 4 and then 3x minus 15 plus 7 is equal to 12x minus 32. Now I can combine like terms in here. I'm going to have 3x and we're going to have minus 8. So I have to distribute the 4th root of those two terms. So 4 times 3x is 12x. 4 times negative 8 is going to be negative 32. That's equal to 12x 12x minus 32. As you can see, it's equal on both sides, so those two are going to cancel out, and I'm going to be left with 0 equals 0, or negative 32 equals negative 32. In this case, again, the variables added out. This one would be an infinite equation, or an identity. Either way you want to look at it. Alright, so let's continue on. These next ones are a little tougher. This is when we're introducing fractions into the equation. Alright, so this first one, I'm looking at this guy, and I have something over 5 and something over 2. Least common denominator in this case is going to be 10. So what I want to do, I want to get rid of these fractions because I don't want to work with them. I know you guys don't like working with them, so let's get rid of them. So my LCD is going to be 10 in this problem. So I want to multiply each one of these guys by 10. So when I multiply, I can cancel out a 5 from both of these, leaving me with a 2. So my first term is going to be 2x. Second one, I cancel out a 2 in each of these. It's going to leave me with a 5. So I have minus 5x. And then on the right side, there's nothing to cancel, and this is going to be equal to 30. So now I can combine my like terms. 2x minus 5x is going to be negative 3x. To get the x by itself, I need to divide both sides by negative 3. X is going to be negative 10. So that one gave me a final answer. Therefore, this is going to be a conditional equation. All right, it's conditional because it's only true if x is going to be equal to negative 10. All right, next problem here. I have 5 over p plus 1/3 equals 6 over p. My LCD here would be 3p. So I need to multiply each term by 3p. Oh, sorry about that. Still getting used to this touch screen. Alright, so I need to multiply each term by 3p. First one, I can cancel the p's. I get 3 times 5, which is 15. Second one, I can cancel the 3's. So I'm going to have plus 1 times p, or just p. And then on the right side, I'm going to have p's cancel out. 3 times 6 is going to be 18. Subtract the 15 over. P is going to be equal to 3. So again, this one's going to be a conditional equation. All right, stepping it up in difficulty a little bit. It's looking at number E here. So E, here's a fraction, here's a fraction. This one doesn't have a bottom, but it would be over 1, of course. All right, my common denominator is going to be x minus 4. So I need to multiply every term by x minus 4. First one cancels out, leaving me with a 2x minus, now I have to distribute this negative 1 through to this set of parentheses. So I have minus x plus 4 is equal to, over here, this cancels out, so I just have an 8. Combine like terms, I'm going to have x plus 4 equals 8. Subtract a 4 over, x is going to be 4. Again, this is a conditional equation because I do get an answer for x. Last one, this one's getting a little trickier. All right, so first thing I want to do, I want to factor this guy. These guys are already in factors. I want to factor this guy. So if I factor this polynomial here, I'm going to get x minus 5, x plus 6. All right. So I already have both of those two factors over here on the right. So for this one, my LCD is going to be x minus 5, x plus 6. Should be similar to when we did rational expressions in our last example, our last lesson. So x minus 5, x plus 6 for each one. X minus 5, x plus 6, and x minus 5, x plus 6. First one is going to cancel out, so I'm left with just 4x. Second one, I can cancel out the term with the 5. I have to distribute the 2 through. So I have plus 2x plus 12. And then on the other side, the equal sign, I can cancel out the x plus 6, distribute the 1 through, and x minus 5. All right, so now I'm going to combine like terms on both sides. I only have this over here, so I have a 6x plus 12 equals x minus 5. I'm going to subtract my x term over. I have 5x plus 12 is equal to negative 5. And then lastly, subtract my 12 over. So I have 5x is equal to negative 17. Both sides by 5. And x is equal to negative 17 fifths, which would also be negative 3 and 2 fifths. Either one would be a correct answer here. And again, this one is a conditional equation because I can get an answer in the final step. All right, so that is the 2 lessons here. They're not too bad. We have a little bit of graphing points, graphing an equation by using points and making a chart, finding x and y intercepts by looking at your graph, solving linear equations, and different ways to identify equations as inconsistent, identity, or conditional. If you have any questions, please refer back to this video at any point. And you have an assignment on these 2. So give it a shot, see how it goes.